Rotation operation. So let's look at the overview. Rotation operations. Yeah. We define a set of local transformations to modify the structure of an AVL tree. The reason is obvious. The reason, the balance factor at some nodes are not in 0, 1, -1 cases. Could be 2, Yeah. Usually, if we start with a AVL tree, suppose, we build an AVL tree first. After that, every time when one new node inserted, so usually the violation will cause some node take balance factor 2. Because you only add one node. So you change the balance factor to -2. You will not do big change. So we will fix that. A rotation can change the balance factor of a node. So to bring down, if it's 2, make it 1, 0, bring it down. If -2, bring it up. -1, 0, within the acceptable range. So we apply a rotation operation on an unbalanced node. Unbalanced, the definition is the balance factor is out of the range. Those 3 numbers. So there are 4 types of rotations. R rotation, right. R means right. R rotation. L, left rotation. Left, right. Okay. These are single rotations. You only do rotation once, so single rotation. Then double. LR rotations. You need to do twice. Left once, right another time. So LR rotation, RL rotation. R first, L next. So double rotations. So let's look at these 2 types one by one. We look at the single rotations first. This part we just look at the single rotations. Next part we will look at the double rotations. Then we can recover any unbalanced BST to AVL type, balanced BST. Single rotations. So let's look at it this way. Right rotation first. So let me give you a simple example. Look at this. This portion is there is unbalanced node in this tree. Okay? Balance factor 2, because based on the definition, 1 minus -1, 2. 1 at second node, 0, node 1, okay? Node 2, So the violation occurs at this place, okay? So we need to use a rotation operation to change it. All right, so now let's do the R rotation with respect to this node, okay? So we write it as R parenthesis 3, okay? R rotation with respect to node 3. Okay? So you just imagine you do rotation. So rotation R, to the right, to your right. Okay? So then you get this. You change the structure in this way. After that, if you look at the balance factor 0, 0, 0. Really good. So that's a nice change. That's the right rotation. Similarly, the left rotation. Because here, this example, although very simple, but not very general. Okay, in order to make this operation more general, in my next slide, I need to add a little more details. So you will see, yeah, we can apply it anywhere in a BST. Yeah, left rotation, similar. Yeah, idea similar, just direction opposite. This time we have the structure like this. So balance factor -2, -1, and 0. This time when we do rotation, we do left rotation with respect to this violation node. This node has a violation, okay? Rotation like that to the left rotation. All right, so we use this L parenthesis 1, left rotation with respect to node 1. Okay, so we get this. So we bring down this to get that. You need to use your imagination a little bit. Okay, bring down. Okay, yeah. Then you update the balance factors of these 3 nodes. Yeah. All right. Now I want to give you the more general case. Yeah. So for right rotation, so this time I want to make a very general. It could be, anywhere in a BST. Yeah. So that's why I make it general. Yeah. So I add subtrees into these 3 nodes. Okay. So the node 1, left subtree, right subtree. So I use that notation. Okay. Height H, height H. Same height, so the difference, That one, the height also H. R, right subtree for node 2. Okay. Then right subtree for node 3 with the same height H. So then you can see the balance factor will match 0, 1, 2. Okay? So this time we have a more general setting. Yeah. Now the violation node, node 3, violation node. So we do right rotation. Yeah. Right rotation with respect to node 3. This time we bring down node 3. Okay, so node 2 at top, and we arrange the subtrees carefully. Okay, so for node 1, it still keeps its original subtrees, 2 subtrees, so no change. But for node 2, it does not need to take its original subtree because it has new subtrees, right? But for node 3, we need to arrange the subtrees in a new way. Right subtree still keeps the same, but the left subtree takes the original right subtree of node 2. Okay? Under this arrangement, you can see, the structure, the balance structure is recovered with new balance factors 0, 0, 0. And we, in order to apply this rotation in the general situation, so we describe it as this R pattern like this. So when we recognize this pattern, so then we will apply this operation. Yeah. Similarly, for the left rotation, we can do the same thing, right? So you can see this time we have a BST like this. Okay, this time we do left rotation with respect to this violation node. Okay, L parenthesis 1. We bring it down, then we need to attach those subtrees. Node 3 keeps its original 2 subtrees. Node 2, the existing subtrees. Node 1 keeps its left subtree, but its right subtree, modify, update it from node 2's left subtree. Yeah. So you can see in this way, we can adjust the structure of BST with violation rule on certain nodes. Violation with respect to the AVL rule. Yeah. All right, so the pattern, we can also get that pattern, L pattern like that. So we can match, recognize, apply it. All right, so that's the single rotation operations. Next part, we will look at a double rotation operation. It will be more complicated than this one.